Welcome back to Tech Exercise and Google Cloud Platform tutorial series. With the thumbnail, by now you must be aware that I'm going to talk about BigQuery performance improvement techniques and the associated services provided by Google BigQuery. It is partitioning and clustering. Both partitioning and clustering used to optimize the performance of a query and the cost associated to it. So what is the difference? Partitioning basically splits a table into smaller chunks or segments. It is known as partitions. There are two types of partitions. One is default partitions or ingestion time partition. When data gets ingested into a table, that time partition gets created. Second one is column based partitioning or the user defined partitioning, where you have the flexibility to define your own chosen attribute as the partitioning column. You can define be it day wise partitioning, hour wise partitioning, or month wise partitioning. There is one limitation that one table cannot have more than 4000 partitions till now. In future it might extend. Moving ahead to the clustering. Clustering basically sorts the data present within a column. So when you use clustering column in your filter clause, it will go and scan the data based on the sorted order. So that's how it improves the performance. Now quickly we'll jump into the practical scenario, how it works. I can show you the improvement we can get. So let's dive into this. First of all, I have a sample file which I have placed in my storage bucket, and I'll try to create a table from this file. It is a customer file, and we'll look at the data once it's get loaded into a BigQuery table. We'll create a dataset, create dataset, BQ demo dataset. Region is single region, US East, create dataset. Once the dataset gets created, I'll hit the create table button and I'll choose Google Cloud Storage. And with the browse properties, I'll opt for the file. Select file format is CSV, table name is customer. Now schema I'll choose as auto detect. I don't want partitioning and clustering for this table. In the advanced option, I will skip one row as the header. I'll hit the create button. While it takes some time, I'll try to move the video. That's all. I could see now table got created. If we see the table, it has 2 million record and the size is 345 MB approx. This is my first table where I don't have any partitioning and clustering defined in it. So let's query this table. If you see this notification, it says this query will process 345 MB approx when it runs. So basically it is scanning the entire table, right? If I scan, I'll get the data. So let me run this. I can see the data. Now this is the job information. If you see, it took 8 seconds to retrieve the data from this table. It processed 345 MB data approx. Bytes built for 345 MB. Slot millisecond it took 48378, and this one I'll try to copy. Now if you see the data, it has the index, it has the customer ID, first name, last name, company, city, country, phone 1, phone 2, email, subscription date. Since I don't have ingestion date time, I'll use the subscription date as my partitioning column and I'll try to see how it works. Similarly, I will choose country and city as the clustered columns. Having said that, I have a script which will create a partitioned and clustered table out of the existing table. So let's create this table, and that's all. We could see our table got created. Now I'll try to select from this table, or we can see from here also the configuration details. Now if you see, this table is partitioned day wise. Partition on field, subscription date, partition is not expirable. Partition filter is not required, and if we see, clustered by country and city. So this table is properly configured. Now we'll see the difference, how it makes. So I'll try to use both the table and see how much optimized it is. Select star from partition table. At the same time, I'll use select star from non-partitioned and clustered table. So I'll use specific filter. Let's say date, I'll use this one, where subscription date equal to this, and country, let's say Italy. Okay, and I will use the same where clause in partitioned and clustered table as well. Now let's analyze the difference. First I'll hit the query for non-partition table and I got the information. So it took basically 0 second. Bytes processed 345 MB, bytes built for 345 MB, slot milliseconds 1657. So I'll try to copy to check the difference. Now I'll hit the same query for the partition table. Now if you see the job difference, bytes processed is only 404.49 KB, where it was 345 MB, here it is only 400 KB approx. Bytes build, it is only for 10 MB, and here it was 345 MB. The slot millisecond used is 86, here it was 1657. So that's how you can see it makes a huge difference when you use partitioning and clustering associated to your table, and when you are not using partitioning and clustering. Using these two techniques, you can improve the performance. One more keynote I would like to add, that it can improve the performance, and you can see it when your table is huge in size. For smaller table, it is not recommended. Even though you can use it, there is no restriction as such, but you won't be able to see the performance. It is kind of negligible. I think that's all for today. Keep watching my video, and if you haven't subscribed, please do subscribe, like, comment and share. Thank you. I'll see you in the next video. Have a great day. Bye bye.